A doorbell transformer can share a circuit with another alternating current circuit on a single breaker, provided several conditions are met. Firstly, the breaker must have sufficient amperage to handle the combined load of both circuits. This means adding up the amperage draw of the existing circuit and the doorbell transformer to ensure the breaker's rating isn't exceeded. Doorbell transformers typically draw very little current, usually around 10 to 20 volt amps, so they are unlikely to overload a breaker on their own, but the existing circuit's load must be considered. Secondly, the wires used for both circuits must be of an appropriate gauge for their respective amperage ratings. Wire gauge refers to the thickness of the wire, and thicker wires can safely carry more current. Consult an electrician or reference the National Electrical Code (NEC) to determine the correct wire gauge for the breaker's amperage and the length of the circuit run. Using undersized wires can lead to overheating and fire hazards. Thirdly, the circuit must be protected by an overcurrent protection device, such as a fuse or circuit breaker, rated appropriately for the total amperage. The overcurrent protection device is designed to trip or blow if the current exceeds the breaker's rating, protecting the wiring and preventing fires. It's crucial to use the correct size breaker for the wire gauge and the circuit's intended load. Fourthly, the installation must comply with all applicable electrical codes, including the National Electrical Code. The NEC sets standards for safe electrical installations. Local codes may have additional requirements. It is important to be familiar with these codes or consult a licensed electrician. Double tapping, which means connecting two circuits to a single breaker terminal, is generally allowed for circuits with similar usage patterns and amperage requirements. This practice should only be done if the breaker and wiring are rated for the combined load. Also, ensure the breaker terminal is designed and rated for multiple conductors. It is important to ensure that the wires are properly connected and secured to prevent short circuits or electrical hazards. These connections can cause arcing, which generates heat and can lead to fires. Use appropriate wire connectors and ensure they are tightened securely. The doorbell transformer is unlikely to overload a breaker because they draw very little current, typically around 10 to 20 volt amps. However, the total load in the circuit must be considered to ensure the breaker is not overloaded. If the existing circuit already draws close to the breaker's maximum amperage, adding a doorbell transformer could push it over the limit. Calculating the total load involves adding up the amperage of all devices and appliances on the circuit. Refer to the appliance's nameplate for its power consumption in watts per volt amps, and use the formula amps equals watts divided by volts to calculate the amperage. For example, a 100-watt light bulb on a 120-volt circuit draws approximately 0.83 amps. If the total calculated amperage exceeds 80% of the breaker's rating, it is best to install a separate circuit for the doorbell transformer. Overloading a circuit breaker can cause it to trip frequently, which is an inconvenience and a sign that the circuit is not adequate for the load. Repeatedly tripping a breaker can also damage it over time. In severe cases, overloading a circuit can lead to overheating, which can melt the wire insulation and cause a fire. If you are unsure about any aspect of the installation, it is always advisable to consult with a licensed electrician to ensure that the installation is safe and compliant with all applicable codes and standards. An electrician can assess the existing wiring, calculate the load, and make recommendations for safe and reliable installation. They can also ensure that the installation meets all local and national electrical codes. When working with electricity, safety is paramount. Always turn off the power to the circuit at the breaker before working on any wiring. Use insulated tools and wear appropriate safety gear such as gloves and eye protection. If you are not comfortable working with electricity, it is best to leave the job to a qualified electrician. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and your property. Furthermore, consider these points. Firstly, understanding breaker capacity. A circuit breaker's primary function is to protect electrical circuits from overcurrents, which can lead to overheating and fires. Circuit breakers are rated in amps, indicating the maximum current they can safely handle. Standard residential circuit breakers are commonly rated at 15 amps, 20 amps, or 30 amps. The rating of the breaker should match the ampacity of the wiring and the anticipated load on the circuit. Secondly, calculating circuit load. To determine if a doorbell transformer can be safely added to an existing circuit, it is essential to calculate the total load on the circuit. This involves summing the amperage draw of all devices and appliances connected to the circuit. For appliances with power consumption listed in watts, use the formula amps equals watts divided by volts to convert to amps. Ensure the total load does not exceed 80% of the breaker's rating to prevent nuisance tripping. For example, a 15 amps breaker should not carry a continuous load of more than 12 amps. Thirdly, wire gauge and ampacity. The ampacity of a wire refers to the maximum current it can safely carry without overheating. Wire gauge, measured in American wire gauge, AUG, is inversely proportional to the wire's ampacity. Thicker wires have lower AWG numbers and higher ampacity. The National Electrical Code specifies the ampacity of different wire gauges. For example, 14 AWG copper wire has an ampacity of 15 amps, 12 AWG copper wire has an ampacity of 20 amps, and 10 AWG copper wire has an ampacity of 30 amps. When adding a doorbell transformer to an existing circuit, ensure the wiring is of an appropriate gauge for the combined load. Fourthly, doorbell transformer specifications. Doorbell transformers are designed to step down the standard 120 volts alternating current voltage to a low voltage, typically 12 volts alternating current or 24 volts alternating current, to power the doorbell chime. The power consumption of a doorbell transformer is usually very low, typically ranging from 5 to 20 volt amps. This low power consumption makes it unlikely for a doorbell transformer to overload a circuit on its own. Fifthly, double tapping considerations. Double tapping refers to connecting two wires to a single terminal on a circuit breaker. While double tapping is generally discouraged, it is sometimes permitted under specific conditions. The circuit breaker must be listed and labeled for use with multiple conductors, and the wires must be securely fastened to the terminal. However, it is always preferable to use a pigtail, which involves connecting multiple wires to a single wire using a wire connector, and then connecting the single wire to the breaker terminal. Sixthly, overcurrent protection devices. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overcurrents. Circuit breakers are resettable devices that trip when the current exceeds the breaker's rating. Fuses are one-time use devices that blow when the current exceeds the fuse's rating. The overcurrent protection device should be sized appropriately for the ampacity of the wiring and the anticipated load in the circuit. Seventhly, grounding and bonding. Grounding and bonding are essential for electrical safety. Grounding provides a low impedance path for fault currents to flow back to the source, allowing the overcurrent protection device to trip and to energize the circuit. Bonding connects all metal parts of the electrical system to the grounding system, preventing voltage differences that can cause electric shock. Eighthly, National Electrical Code compliance. The National Electrical Code is a comprehensive set of standards for safe electrical installations. Compliance with the NEC is essential for ensuring the safety and reliability of electrical systems. Local electrical codes may have additional requirements that must also be followed. Ninthly, common wiring mistakes. Many wiring mistakes can lead to electrical hazards. These include using undersized wires, making loose connections, failing to properly ground and bond the electrical system, and overloading circuits. It is important to follow all applicable codes and standards and to take all necessary precautions to avoid these mistakes. Tenthly, troubleshooting electrical issues. If you experience electrical issues, such as frequent breaker tripping, flickering lights, or sparking outlets, it is important to troubleshoot the problem and correct it promptly. These issues can be caused by a variety of factors, including overloaded circuits, loose connections, and faulty devices. If you are not comfortable troubleshooting electrical issues, it is best to consult with a licensed electrician. In addition to these points, consider the specifics of doorbell transformer wiring. Firstly, transformer location. Choose a suitable location for the doorbell transformer. Common locations include near the main electrical panel, in a utility room, or in the attic. The transformer should be mounted in a dry, accessible location. Secondly, wiring connections. Turn off the power to the circuit before making any wiring connections. Connect the transformer's primary wires to the 120 volts alternating current circuit using wire connectors. Connect the transformer's secondary wires to the doorbell chime and the doorbell button. Ensure all connections are secure and properly insulated. Thirdly, voltage testing. After making the wiring connections, turn on the power to the circuit and test the voltage at the doorbell chime and the doorbell button using a multimeter. The voltage should be within the specified range for the doorbell system. Fourthly, common issues. Common issues with doorbell transformers include transformer failure, loose wiring connections, and short circuits. If the doorbell chime is not working, check the transformer, wiring connections, and doorbell button for any signs of damage or malfunction. Fifthly, replacement. If the doorbell transformer is faulty, it should be replaced with a new transformer of the same voltage and volt-amp rating. Ensure the replacement transformer is properly installed and wired according to the manufacturer's instructions. Also consider safety precautions for electrical work. Firstly, de-energize circuits. Always turn off the power to the circuit at the breaker before working on any wiring. Use a voltage tester to verify that the circuit is de-energized. Secondly, use insulated tools. Use insulated tools when working with electricity to protect yourself from electric shock. Thirdly, wear safety gear. Wear appropriate safety gear, such as gloves and eye protection, to protect yourself from electrical hazards. Fourthly, avoid wet conditions. Never work with electricity in wet conditions, as water can conduct electricity and increase the risk of electric shock. Fifthly, call a professional. If you are not comfortable working with electricity, it is best to leave the job to a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and your property. In conclusion, adding a doorbell transformer to an existing alternating current circuit on a single breaker is permissible under specific conditions. Ensuring that the breaker has sufficient amperage, the wires are of appropriate gauge, the circuit is protected by an overcurrent protection device, and the installation complies with all applicable electrical codes. Consulting a licensed electrician is always advisable for a safe and compliant installation.